Okay, we're on functions now, and this is BMQ2C. The question in this case actually is to determine whether the function x map to 2x plus 3 over x minus 1, where x is in the set of real numbers but excluding 1. Whether this function is actually a 1-1 function, and if it is a 1-1 function, then we're supposed to find the inverse function with the domain and the range for the inverse function. So in order to see whether it's a 1-1 function, we first need to remember what is a 1-1 function. A 1-1 function actually just means that for every x there is only one y, and for every y there is only one x. Now because it is already said that it is a function, you don't need to check whether it is 1-to-1 or many-to-1 in this case, because remember there are 4 different kinds of functions: many-to-many, many-to-one, one-to-many, and 1-to-1. Now because they've already told you that it is a function, it can only be many-to-one or 1-to-1. Your job now is to eliminate this if possible. So to eliminate the many-to-one possibility, what you need to do is conduct the horizontal line test. In other words, for every y equals to k, let's say, there has to be at most one value of x. So if we draw this graph out, we change everything back. So if we draw this graph out, then you should see very clearly whether it is or it is not. So you actually have, let me clear this. Oh goodness. So one of the easiest ways to convince the marker is to draw the graph out for them. So x equals to 1 is an asymptote. And what else? X equals to 2. Y equals to 2, sorry. It's also an asymptote. And right, so it looks like something like this, and then label. And we'll therefore, the horizontal route, horizontal line test, this is 1-to-1. Okay, so since it is 1-to-1, The next question is that we have to find the inverse function. So when we find the inverse function, we let y equals to the function first, and then we make x the subject of the formula. So this tells you that the inverse function actually fulfills the condition x plus 3 over x minus 2. So if this function above was fx, this would be f inverse be such that x will be mapped to x plus 3 over x minus 2, and it is not complete. We still need the domain and the exact range. Okay. From the graph of the original function, you see that the domain is actually x in a set of real numbers, but excluding x equals to 1, and the range is negative infinity to 2 non-inclusive union to infinity. In other words, the whole set of real numbers, but excluding the point y equals to 2. So when you're finding the inverse function, these two actually swap around. So I actually have here x is in a set of real numbers excluding x equals to 2. This is my domain, and my range will be let's not use y. F inverse x will be in the set of real numbers excluding 1.